So let's continue with the substitution method, and today we'll see some integration formulas which are derived using the substitution method. So earlier in the lecture we have seen the standard formulas wherein we just know the derivative of the function and we go ahead and find the integration of those functions. But now what we'll do is we'll find the integrals of, so we are going to find the integrals of tan x, cot x, sec x and cosec x. So these integrals can be found using substitution method. Here we are not using the derivative method. That means we are not finding it using the reverse of differentiation, because tan x, cot x, sec x and cosec x are not derivatives of any particular function. So let's start off with the first one, and before we start off, let's just write the the two concepts which we learned in the last lecture, which we are going to use. One is, if you have a function in the denominator, its derivative is in the numerator, and you take the integration, so the answer is ln fx, right? Ln or log fx and plus c. And if you have integration and you have the same function down, the derivative is on the top. However, this time the function is inside a root which is in the denominator, so the answer is 2 root fx plus c. So using these two concepts, let's start off with this one. So the first one, integration of tan x. So now what I'll do is I'll just write I is equal to integration of tan x dx. Now I know tan x is sine upon cos. So I can see cos x, the derivative is minus sin x, but here we have sin x. So we'll do manipulation. So now integration is actually full of manipulations. The more you're good at this, the better it would be to solve sums. So see what I've done. I've just taken minus outside, minus inside. So minus minus becomes plus. Derivative of cos is minus sine. So now this is of this form, of this form. So I can write the answer. So integration of tan x. So let's write this way. Integration of tan x is equal to ln cos x plus c, right? And if you remember, this minus is there outside, so this will be here, right? So now what we can do is, we can, in some books you'll find this written in some other way, so they'll write this way. Ln, now due to the power law, this minus comes here, so I can write this as cos x raised to minus 1 plus c, and cos x raised to minus 1 is 1 upon cos. 1 upon cos is sec, so I can write this answer as ln sec x plus c. So this is the integration of tan x. Got it? So this was the first one. So this obviously you can directly use now. Integration of tan x is sec x. Now let's try the next one, cot x. So cot x is actually very simple. It's in fact it's direct, because you have cot x as cos upon sine, and derivative of sine is cos. So there is no problem. You can just directly write this is ln sine x plus c. That's it, right? Let's try the third one, integration of sec x. So now we're understanding why we're using this method, because derivative of ln sin x, we don't have derivative of ln sin x, a standard formula. So that's why for cot x we need to follow this method, and for tan x as well. Now for sec x. So now sec x, there are two formulas. So I'll use both of them now. The first one, which is normally used in boards, and that is what, so sec x, sec x I cannot write. I can write sec x as 1 upon cos, but that will not, serve a purpose. So what I'll do is I'll write this as sec x, and now I'll manipulate again. I'll multiply and divide by sec x plus tan x, and we'll divide by sec x plus tan x dx, right? Now, so you'll say, why have you multiplied and divided by this? The reason is because this will give me sec square x plus sec x tan x upon secx plus tanx. And now if you carefully observe, derivative of sec is secx tan x, derivative of tan is sec square x. So that's why the answer will be ln sec x plus tan x. Now some people can argue that how do you know we have to multiply with this only? Now the thing is that sec and tan are mostly interrelated, in terms of formulas of derivative and integration. So usually that is what we do. And also, integration, you don't have set methods, so you have to do such manipulations in order to get the answer. Now I'll give you the alternative formula for this one. So let's do the alternative method. So the same formula, I can just go ahead and write this as ln 1 upon cos plus sine upon cos plus c. This can be now further written as 1 plus sine upon cos, right? Now we'll do move manipulation, and this formula which we are deriving, this is more commonly used in JEE, less in boards. So let's continue with this. So we have ln. Now see what we are doing. 1 plus sine x. Now 1 I can write as sine square x by 2 plus cos square x by 2, and sine x I can write as 2 sine x by 2 cos x by 2. Now these are all trigo formulas, okay? So before you start off with integration, your trigonometry, you should be good at trigonometry. And now cos x is cos square x by 2 minus sine square x by 2, right? Now if you can observe this, this is actually what? This is sine x by 2 plus cos x by 2, the whole square. And in the denominator, it's a minus b, a plus b. So I can write this as cos x by 2 minus sine x by 2 into cos x by 2 plus sine x by 2. So little boring, but that's the method. And then later on you can just remember the formula if you want. So see, this one term will get cancelled. So you're left with this. Now what I'll do is I'll divide numerator and denominator inside the log by cos x by 2. So what I'll get is I'll get 1 plus tan x by 2 upon 1 minus tan x by 2. Now we can simplify this more. 1 I can write as tan 45, which is tan pi by 4 plus tan x by 2 upon 1 minus tan pi by 4 into tan x by 2. The reason is because tan pi by 4 is 1, right? And instead of 1 I can write this, and now this is the formula so of tan. So tan a plus tan b upon 1 minus tan a tan b, that is tan a plus b. So tan pi by 4 plus x by 2 plus c. So this is the other formula for integration of secx, right? Similarly, the fourth one, so now this, if you want, you can try, you can give it a try, the integration of Cosec, right? So integration of Cosec, again, you will start off with the, similar manner. You will multiply and divide. This time, you will multiply and divide by, because Cosec and cot are interrelated, and I'll multiply and divide by cosec minus cot upon cosec minus cot. And now if you observe carefully, the derivative of the denominator is in the numerator. So the formula is ln cosec x minus cot x. Now in some international books, you'll find cosec written as cscx minus cot x, okay, plus c. Now again, here you have an alternative formula. So the alternative formula is, so what you do is you take this further, and you write this as ln 1 upon sine x minus cos x upon sine x. Okay. So now this will be, see, this will be ln 1 minus cos x. Now 1 minus cos x is actually, the formula is 2 sine square x by 2, and sine x can be written as 2 sine x by 2 cos x by 2. 1 sine x by 2 gets cancelled. So what you're left with is ln tan x by 2 plus c. So this is the answer. So these are the formulas which we derived using the substitution formula, and I mean the substitution method. And now in the other lecture, next lecture, we'll use these formulas in the questions wherever possible. So hope you like this video. Till next time, please take care of yourselves. Take care. Bye bye.